Suppose we have a system that's supposed to amplify an input signal here by 10 to give an output signal here. But unfortunately, this system suffers a problem where noise is added in to the output, so you end up with X out being 10 times the input here plus the noise. That's not good. I'd like to reduce that noise if possible. That noise is really just a disturbance to my whole system. So what I want to do is I want to show you how to reduce this noise using negative feedback. What we'll do is we'll sample the X out here, and we will multiply that sample by 1/10. And then we will take the place where we were going to put our input signal, and we will put a really big amplifier here with a large gain A. Then we will put in a little summer here, which will take the difference between what we're now going to put in, which I'll call XS. It's going to sum here, it's going to take XS, and it's going to subtract this value right here, which I'm going to call XF. And this XF will be this 1/10 times X out. Let's look at how this works. This is a linear block diagram, so what we can do is we can find out first the output due to XS and then the output due to N. So if we do that, we end up with X out equals, and if you recall, this whole thing right here is like a big gain of 10A. So it's going to be 10A over 1 plus, it's going to be beta, which is 1/10, times the gain, which is 10A. And then I've got to multiply that thing by XS, because this is like the XF here, as you remember from the last video. So this is times XS. Now I'm going to find the output due to the N. On this, when I was doing this, I basically turned N off and used superposition to find the output due to just XS. Now to find the output due to N, this is actually also a feedback block diagram with the, if you look at here, this being plus and that being plus, what we have here is a feedback block diagram where our A is just 1. So I'm going to have 1 over 1 plus the beta. The beta this time is 1/10 times, this guy is 0, so the sum doesn't do anything, and by the way, this needs to be negative. So we have basically the beta is this guy times that guy times that guy, which gives me an A, because 1/10 times 10 is 1 times A. And then I have to multiply that by the N. So notice we end up with this as our output. So if you notice here, if we take the limit as A goes to a very large number here, this 1 doesn't really matter. The 1/10 and the 10 cancel on the bottom. The A cancels with that, and you get X out equals 10 times XS, plus this other part over here, which is 1 over 1 plus A times N. And A was getting very large, so this thing right here goes almost nothing. So instead of just having the noise adding in, the noise is almost invisible now because this A is so large. That's the benefit of feedback that you get by applying negative feedback when you have a situation of a noise being added into your output, a disturbance on your output. This also works for such things as feedback and control systems for missiles. For example, you shoot off a missile, and then you see for some reason the output is changed. Somebody's changed the direction of the output, but then what happens is that changes the direction that your missile that's trying to shoot their missile is going, and it corrects and it eventually chases it down, hopefully. So this is negative feedback, gives us a big boost when it comes to reducing external disturbances like the noise right here.